All right. This is geometry, chapter 4, 4.3. This would be Miss Gracie. 4.3. So we have congruence postulates. Congruence means things are the same. Okay? Let's see here. Mostly we're going to be talking about triangles, okay? So when we have triangles, if these two triangles, wow, congruent means like the same, right? Congruence postulates. Different things we're going to be looking for is this. Okay, you say this side and this side are the same, this side and this side are the same, this side are the same. Okay, if I have all the sides are the same, then this one is going to fit right on here. Okay, if I have, how do I do this? There's this side and this side are the same, this side and this side are the same, and this side and this angle, angles are the same. So this angle is congruent to that angle, this angle is congruent to this. These are congruent triangles, okay? So I want to be able to prove this. The first thing we're going to do is it's called side angle side. So side angle side. It's supposed to be an S. Side angle side. So if I have a triangle like this and I have another triangle over here like this, if I have a side and then I have an angle and then I have a side. All right, so this is side angle side. This angle is between these two sides. The angle is between the two sides. Understand what I'm saying? The angle has to be between the two sides. If I have this, okay, if I have this length and I have this angle and this length, when this side goes on, it has to match this side. There's no choice. And the angle that it forms has to be the same there, and the angle that it forms here has to be the same here. Because this is a set length, this is a set length. Set side, and the angles are the same. Therefore, what they open up to and the thing where the line that connects them will always be the same. This is called side angle side. Okay? The thing to remember is it has to go in that order. It's side angle side. Not that there's just two sides and an angle. It's the angle is included between the two sides. Okay, it's page 163. Page 164, we have angle, side, angle, all right? Angle, side, angle. So what this means is we're going to have the side included between two angles. Okay, so I have a side, let's say this side. It's between this angle and this angle are the same. And this one. It's angle, side, angle. Angle, side, angle. The side is between the two angles. Again, if this is a set length, and this angle right here has to be what it is, and this angle has to be what it is, when we extend these two lines out, they will always meet at the same place. Wow. They will meet at the same angle, and this length will be the same, and this length will be the same. This is angle, side, angle. Okay? So what they're asking you for is to look at example number 3 right there. Okay? On the example number 3, we have a thing that is called actually a kite. Okay? My kite is probably not going to fly very well because it's my kite. So what this says is this side and this side are the same, and this angle and this angle are the same. Now, to prove that these are congruent triangles, here is a triangle, here is a triangle. How do I know that they're the same? The reason I know, and the way I'm going to do it, it's going to be side angle side. I have a side here and a side here. I have an angle here and I have an angle here. Now, I don't know anything about this angle or this one or this one or this one. But I do know something about this side right here. This side, which is the same on both of them, is equal to itself. Sounds kind of ridiculous, but it is. So what I have is side, angle, side, that I know these two are congruent because that side has to be equal to itself. Okay, and on the assignment there, I've told you what to do, which ones. If you look at 7, I don't know, through 15, it says triangles can be proved congruent using either that side angle side or angle side angle. If they can, write the valid congruent statement and name the postulate that justifies it. They're saying, do I know, like on number 7, if I look at those two angles, how do I know they're congruent? Well, I have it side, angle, side. Over here I have side, angle, side. So side, angle, side is what I have. So the triangle congruence would be, if I want to start at A, ABC. Triangle ABC equals triangle what for the other one? If I start at A on that one, I'm going to start at E on that one. So it's going to be EFD. And it's going to be side, angle, side. So this states the congruence. This shows what postulate it is. Side, okay? So this says it's this triangle and this triangle. Have to start at the right places, go to the right places like this, and this tells what it is. If there's not enough, if it doesn't, look at number 9. Number 9 has all 3 angles the same. Now, if all, because the angles, the way they're marked there, that makes it an equilateral triangle. Okay, now, all I know is that there's 2 equilateral triangles. I know that they all have 60-degree angles, but I don't know anything about sides. So I can't have triangle congruence without knowing the lengths of the sides. Because I can have this and I can have this. All the angles are the same, but the sides are definitely the same. So this is not triangle congruence unless I knew, like if this is A, B, C, this is D, E, F. If I knew that A, B was congruent to, I don't know, D, E. If I knew this, then I would know that I had congruent triangles and I would have angle, side, angle. If I knew this, but I don't. So the answer is, on number 9, what do I have to know to show that it is triangle congruence? I'd have to set at least 2 sides equal to each other, and then I could have triangle congruence. That's how you do that. Okay?